Okay, I'd like to define P to be the plane containing these 3 points, A, B, and C, and I'd like to find a vector that's perpendicular to the plane. In other words, if you have a plane, just like imagine a piece of cardboard that does not move very much as your plane, and you wanted to create a vector that's perpendicular to the plane, that'd be like if you took that cardboard and you pierced it with a pencil. And so, what direction does that pencil face? So, here's one way to answer this question. We have these 3 points A, B, and C that are in the plane. Well, why don't we create the vector from A to B and the vector from A to C? It's a multi-step process. And then once we have these vectors that lie in the plane, they live in the plane, then we could take the cross product of those two vectors to get a vector that points directly out of the plane and is perpendicular to the plane. So the thing to try to note about this picture, sorry, I don't mean it to be deceptive, but it's hard to draw these things, is that the points A, B, and C, as well as the vectors u and v, those all live inside the plane. And so since u and v are both in the plane, if we take the cross product, we'll get something that's perpendicular. So there's the vector AB. Here's the vector AC. And then if we take the cross product of these two, we'll get -2, -8, 6. Or, of course, you could write this in an IJK format as well. Okay, so this vector here is the one that points out this way. Okay, and in fact, in the end, any non-zero multiple of the vector here is also correct. If you just scale this vector by multiplying by 2, it's still perpendicular, it's just a longer vector. If you multiply by -1, it's just a vector that points down instead of up.